A working substance goes through a cycle within which the absolute temperature varies n-fold, and the shape of the cycle is shown in figure A and figure B, where T is the absolute temperature and S the entropy. Find the efficiency of each cycle. Solution: from the figure shown, we know that the area of the graph gives the total heat given, since dq equals to Tds. Now heat added Qa equals to Ta into S2 minus S1, and work done equals 1 by 2 into under bracket T2 minus T1 into under bracket S2 minus S1. Hence eta equals to work done by heat added equals to 1 by 2 into under bracket T2 minus T1 into under bracket S2 minus S1 by T2 into under bracket S2 minus S1 equals to 1 by 2 into under bracket 1 minus T1 by T2 equals to 1 by 2 under bracket 1 minus 1 by n equals to 1 by 2n into n minus 1. Hence eta equals to n minus 1 by 2n. A. Given that T2 by T1 equals to n, work done equals to 1 by 2 T2 minus T1 into under bracket S2 minus S1, and heat added equals to 1 by 2 under bracket T2 minus T1 into S2 minus S1 plus T1 into under bracket S2 minus S1. Hence eta work done divided by heat added equals to 1 by 2 under bracket T2 minus T1 into S2 minus S1 divided by 1 by 2 into T2 minus T1 into under bracket S2 minus S1 plus T1 into under bracket S2 minus S1. Hence eta equals to T2 minus T1 divided by T2 minus T1 plus 2T1 equals to T2 minus T1 by T2 plus T1. This gives eta equals to under bracket T2 by T1 to the power minus 1 divided by T2 by T1 plus 1 equals to n minus 1 by n plus 1. One of the two thermally insulated vessels interconnected by a tube with a valve contains nu equals to 2.2 moles of an ideal gas. The other vessel is evacuated. The valve having been opened, the gas increased its volume n equals to 3.0 times. Find the entropy increment of the gas. Solution: since other vessel is evacuated and the valve is open, this process occurs at constant temperature. The temperature remains same, only the volume is changing. Due to isothermal process, d equals to nu Cv dt equals to 0. Hence from first law of thermodynamics, dq equals to d plus dw, 0 plus pdv equals to nu RT into dv by v. Hence entropy increment delta S equals to integration dq by t. Hence delta S equals to nu into R into integration of v1 to n v1 dv by v equals to nu R log n. Putting all the values, nu equals 2.2 mole, n equals 3 and R equals to 8.31 joule per Kelvin per mole, we get delta X equals to 210 joule per Kelvin. A weightless piston divides a thermally insulated cylinder into two equal parts. One part contains 1 mole of an ideal gas with adiabatic exponent gamma. The other is evacuated. The initial gas temperature is T1. The piston is released and the gas fills the whole volume of the cylinder. Then the piston is slowly displaced back to the initial position. Find the increment of the internal energy and the entropy of the gas. resulting from these two processes. When a position is released, the gas will occupy the total volume and the expansion will be adiabatic. Now Pv to the power gamma equals to C for adiabatic process. This implies P1 V1 to the power gamma equals to P2 V to the power gamma equals to nu R T1 by V1 into V1 to the power gamma equals to nu R T2 by V2 into V to the power gamma. This implies T1 by T2 equals to nu2 by nu1 to the power gamma minus 1 equals to 2 to the power gamma minus 1. Hence T1 is equal to T2 into 2 to the power gamma minus 1 equals T0 into 2 to the power gamma minus 1. Now the change in internal energy d equals to nu Cv dt equals to nu Cv T1 minus T2 equals to nu Cv T1 minus T2 equals to nu Cv T2 into 2 to the power gamma minus 1 minus T2 equals to nu into Cv into under bracket 2 to the power gamma minus 1 into T2 equals to nu R by gamma minus 1 into under bracket 2 to the power gamma minus 1 into T0. Hence T2 equals to T0. Since it finally returns to original position, from the change in entropy ds equals to integration dq by t. When it expanded adiabatically, the entropy change will be 0, but after isothermal compression, slow compression, there will be some entropy change. Hence dq equals to d plus dw equals to p dv equals to nu rt dv by v. Hence delta s equals to integration dq by t equals to nu r into integration v1 to v2 dv by v equals to nu r log v2 by v1 equals to nu r log n. For 1 mole delta s equals to r into log n. Answer.